So this is the TaxWave 5G Spectrum Analyzer probe. It's a low-cost solution to monitor spectrums at 24 to 29 gigahertz with a built-in antenna, frequency agile local oscillator, and touchscreen controls. It's compatible with most low-frequency portable baseband spectrum analyzers, and the analyzer probe is an ideal solution for field spectrum survey and other 5G maintenance tasks. So right now what we're doing is we're setting up the analyzer probe by changing the center frequency that it's looking for. The dials on the left change the gigahertz frequency by 1, and then the ones on the right change it by 0.1. After completing the setup frequencies, now we can actually look at a real-life demo of how this would work. From our laptop, we will be outputting a certain frequency of 12 and then switching it to 12.25, which should equal a 24.5 gigahertz frequency. As the video shows, when the gigahertz goes up by any value, the actual spectrum graph also moves up. So now we're going to be setting up the probe analyzer one more time. We're going to be shifting the value up from 24.5 to 25.5. And then that's going to set the frequency range between 25 and 26. So the peak that was on the very far right of the actual viewer is now located in the middle. And then when we switch this to 12.75, which would be around 25.5, then we can see that the viewer shifts over to the right a few more. And when we switch to 13, which would be 26, the peak goes off the graph. So now we'll be repeating the process one more time, setting it up from the range of 25 to 26, and then we're going to be switching the center frequency to 26.5, which would make the range between 26 and 27. So when we look at the spectrum analyzer again, we can see that the peak is back in the middle, between 0.5 and 2 gigahertz. And so when we switch it to 13.25, which is 26.25 gigahertz, we can see that it shifts over, and then when we switch to 13.5, which will be 27, then it shifts off the grid. The third setup is going to be switching the center frequency from 26.5 to 27.5, so it'll be between 26 and 27. By looking at the spectrum analyzer one more time, we can see that the peak is in the middle of the graph again, and then by switching it to 13.75, which would be 27.5, and then we can see that the peak is between 1 and 2 gigahertz on the spectrum analyzer. The fourth and final shift of this demo will be setting the frequency to 28.5, which should set the range from 28 to 29. So this is our limit, which is 24 to 29 gigahertz, shown between the ranges of 1 to 2 gigahertz. As shown on the numbers on the right, 14.25 gigahertz, which should be 28.5, shifts over on the spectrum analyzer to the right, and then 14.5, which would be 29, shifts it off the screen.